Welcome all of you for today's last session of this course, Smart Grid Basic to Advanced Technologies. And today we'll be going through questions of all the weeks. So it's a summary of entire weeks. Let us begin with week one, and you can find the recording for the lecture on the same link. We'll start with week one questions. First question is, which is or are the boundaries of the customer domain? So, yes, B is correct. So energy and service interface is the boundary for the customer domain. Within customer domain, we can have several customers with in each of them having their own utility meter. The entire domain will be having one boundary, which is this.
I think it is both is the both is the answer.
No, ESI is correct because in customer domain is considering all the consumers. And the in domain in customer domain there can be several customers and each will be having its own utility meter. Okay, so when we say domain, then we consider all the consumers, and so it will be ESI. Okay, the next question is, which domain is responsible for smooth operation of power system? So it's an easy question. What's the answer? Distribution, service provider, markets, or operations?
Sir,
Which one?
service provider.
No, no. Answer is D. Operations. So operation of power system will be in the hands of operation. For India, which is the operation domain? Who is responsible for maintaining the smooth operation of power system in India? Yes, POSOCO. So it National Load Dispatch Center or POSOCO. So it is our operations domain. Operations is correct. So market will help in clearing the market. It will provide a platform for both generators and consumers to bid, and then market will be cleared. So that is the work of market. But what is happening on the entire network, that will be observed or monitored by the operations. The third is, the electrical distribution system can be arranged in which of the configurations? Radial, looped, meshed, or all of the above? Hmm. Yes, D is correct. So answer will be D for this. It can be radial, looped, as well as meshed. All of the above. And next question is, which of the following is one of the key features of a smart grid? Limited sensors, pervasive control, centralized generation.
Pervasive control, sir.
Yes,
B.
this for smart grid we require pervasive control. Each and we want to have a good control over everything. For that we need all this ICT, communication and information technology, in addition to the existing power system. So next is, the meter concentrator is responsible for supporting communication with the meters over the neighborhood area network, LAN, wireless.
Nan,
Or, yes, that is correct. This is neighborhood area network. Next
Sir,
is,
Explain, sir, then little bit.
So in this configuration, what is happening when the meter concentrator is there? So if there are several meters and there is one, suppose there are several homes and these are different meters, and the data of these meters will be sent to this one concentrator. So it's near all these meters. A few homes can be clubbed together and then data, let's say for one feeder, it can be sent to one concentrator. Then that concentrator will send the data to the master. So this is over neighborhood area network. And for this we can use LAN. Okay.
Yes, yes.
Okay, sir.
The next is which of the following quantities is not measured by smart meter measurement?
So voltage sag.
Yes, correct. Voltage sag is correct. They can measure power factor, RMS voltage as well as energy consumption. Then next question is the objective of ancillaries operation in the market domain is to provide cell power to end user, provide frequency support, make a particular market function smoothly, or participants in the market.
Provide frequency support.
Yes,
Frequency support.
yes, this is correct. Ancillary operation objective is to provide frequency support. So it's one of the uh, ancillary services. We can have other also, like start and voltage control ancillary services. Now, these are I have given this again. What you can do is you can use these slides and somewhere in between I have mentioned some important with concepts which are required, so you can go through them. So ancillary services, frequency control, network control, and system restart or black start. So all these fall under ancillary services. This is important to remember. In frequency control, we have these three: primary reserve, secondary reserve, and tertiary reserve ancillary services. And this first one is based on governor action, second one is based on AGC signal, and third one is spinning reserve or non-spinning reserve based. So you should also remember these duration operation. This is fastest, so in order of cycles. This is within few seconds. It will operate, and then it's in the order of minutes. And this requires sufficient communication also. And secondary requires communication. So and tertiary is means this is also communication, but not that wireless communication. If this is manual, means that generator can be asked to provide that reserve. But these two are automatic. This governor action is already there in the control for each generator, and this is through communication. The control signal is sent by communication. So this requires significant communication. So next is standard. Which standard belongs to the wide area situation awareness? So you should remember these standards, important standards. So this is also an important standard. These three are very important. So which one is for wide area situation awareness? You are we also
I
call
think it is D. This is guess
D,
only.
madam.
yes,
IEEE C.
yes. D is correct. So C37.18. So synchronized phasor measurement and all that comes under in this standard.
Sir, how one can remember this?
And now it's we just again and again if we see we can remember. It's most important. these three are very important. Means one is this. This is
Sir,
regarding the DGs, integration of DERs. This is most widely used in for distribution system. Who is speaking?
yes, sir.
So this is for integration of DER and this is for time synchronization.
Yes, sir.
And this one is for VASA or situation awareness. Then there is also that substation automation for it's IEC 61850. You can see here integration of DER. This IEEE 1547. You should remember this one. You should remember this IEEE C37 for VASA. For substation automation, IEC 61850. Time synchronization, this, and cyber security also. So these are some important standards which you should remember. Okay,
Yes, sir.
now we'll move to the week two. So week two, first question: which of the following components of SCADA consist of a human-machine interface?
Master station.
Yes, this is correct. Master station. Which of the following components of SCADA presents data to the master station? Data processing application. This is also correct. So you can see it here. So all these are component of RTU, central real-time database. Then field IO application. They interact with the field equipments. And then IED through communication. Data is collected from IEDs. And then after processing, it is sent back to the master station. It can again receive commands from master. Next is which of the following is not a cause of series resistance of a solar cell? Movement of current through emitter and base, contact resistance between metal contact and silicon, manufacturing defects, and resistance of top and rear metal contacts.
It's C, sir. C, manufacturing defects.
Manufacturing defects.
Yes, so this is for the shunt one, shunt resistance. We should also remember this, the equivalent diagram for solar cell. This is the series resistance and this is the shunt and this is photo generated current. So it's a current source. So next is which of the following components of a wind energy system supports the weight of the rotor?
B answer. Low, low speed shaft.
Which one? Low shaft. Yes, correct. Answer is low speed shaft. And nasal does not consist of which of the following?
Wind.
Gearbox, high speed shaft, wind vane.
Wind.
Wind and vane, sir.
Yes, wind vane is at the end of the nasal. You can see it here. Nasal here. This is wind vane and anemometer. Both are outside. And your drive is also outside. This is here your drive. There are two types of control. One is your drive and another is this pitch control. Then
Pitch control inside. Pitch is inside, no? Pitch
it
is
is
outside.
on the rotor blade. So it's on the rotor hub.
Okay.
Nasal is behind that.
Okay, understood.
This part is nasal. On each blade we have these servo motors on each of these blades which control this pitch angle. And define the characteristics. So you have to tell what are the axes for both the curves, x and y axis for both the curves from current, power, and voltage.
It's A, sir. A. IV curve and PV curve.
A.
Oh, all are I have written all A. Sorry, A B C D. So which one? Which one you are saying? This
A,
one.
sir. A. IV curve and PV
Yes.
curve.
A is the correct.
Correct. This is I and this is V and power and voltage. Correct. The answer. Then the maximum power delivery by a solar panel is 1008 watt, and the open circuit voltage is 72 volts. Short circuit current is 20 amperes. Then what is the fill factor of solar panel? So how will you find this fill factor? How is fill factor defined?
It is a ratio. It is a ratio of
Ratio of
short circuit current into VOC.
no, no.
It is a reverse. VOC.
Yes,
Yes.
denominator is that, and here it will be V maximum. So so how are you going to find out?
So 1008 divided by 72 into 20.
Yes. What's the answer?
Sir.
How much is it?
Point 0.7, sir. Point 0.7 is the answer.
Yes, 0.7. Correct. D. So next is in the fixed speed wind turbine. The speed of turbine is controlled by controlling
Pitch of the wind.
yes,
Which of the wind
correct.
speeds?
Pitch of the wind speed. And next is what is the function of yaw drive in the wind turbine?
C, sir. Turns the rotor according to the wind direction.
Yes. So yaw drive turns the entire rotor, and the pitch drive turns only individual blades of the rotor. Next is the light generated current in solar cell depends on short circuit temperature coefficient, cell temperature, cell short circuit current, or all of the above.
All of the above, sir.
Yes, it depends on all the three quantities. In week 3, which of the following matches is false? Which of these combination is false? Pumped hydro is a hybrid ESS, lead acid is electrochemical, biofuel is chemical, and battery and flywheel are hybrid.
Biofuel and chemical. No, this is true, I think.
Which one? C. Are you sure?
A.
Yes, A is correct. Pumped hydro is not a hybrid energy storage. Biofuel is correct. Pumped hydro is a mechanical energy storage. Right? Can you give an example of any other mechanical energy storage? One or two
It's
examples.
flywheel, sir. Flywheel.
Flywheel.
Yes, correct. Flywheel. Then we have compressed air energy storage. Then we have gravity energy storage. Okay. Next is which of the following storage technology has not so good cycle life? Means life cycle is not that good. Hmm. Correct. So which one?
Lead acid, sir.
Lead acid. Even in we see in our cars also every 3 or 4 years we have to replace the battery. So all these automobiles they use lead acid battery. Yes, you want to ask question?
Sir, what is redox flow, sir? Redox flow means we have not heard of it.
Uh, it's based upon redox reaction. It is also electrochemical energy storage. One example is vanadium redox flow battery. It's based upon redox reaction happens within this. So they have separate electrolytic contain tanks. So one advantage of these redox flow battery is that we can individually size their energy and power capacity. If we increase this tank size, then we can increase the energy capacity. That is not possible with uh, these lithium-ion batteries. If you want to increase one, other will also. There is a restriction. Okay, so next is minor complexity is a significant advantage of which battery modeling methods? Anyone? Its answer is its empirical method is very simple. We just have equations, you can solve it. Electrochemical will be the most difficult one. You have to write equations for both electrical system and chemical system. That will be the most detailed one. And next is what is the disadvantage of lithium ion battery? High potential difference, self discharge rate, and degradation effect. None of the above. Yeah, degradation effect, and this degradation is because it depends on both depth of discharge and discharge rate. More the discharge rate and more the depth of discharge, more will be the degradation of the lithium-ion battery. Suppose the objective function of an optimization problem is convex, then which of the following is true regarding the overall optimization problem? Non-linear constraint always result in a non-convex problem. Linear constraint always result in convex optimization. Linear constraint may result in non-convex, and non-linear constraint may result in non-convex. So objective function is convex. So what is correct?
B is the correct.
B and only B? D is
D.
D is also correct. So you can see here all these I have listed all the possible optimization problems. If variable is continuous, objective and constraints are linear, then it's a linear program. If the objective becomes quadratic, so quadratic is also a non-linear objective, but we have these class of this is convex. We have quadratic programming, and we have efficient solvers to solve this. Then, if variables are continuous, objective, convex, and differentiable, we have convex optimization. If it is not differential, then non-linear programming. Non-convex and differentiable, non-linear, and non-differentiable, non-smooth. So you can go through this. And next is what is and are the significant advantages of hybrid algorithms estimating battery SOC? More effective, high precision.
All.
Yes, correct. All of the above. The two battery aging phenomena are conditional and cyclic. Conventional And calendar aging, calendar and inherent, or calendar and cyclic aging?
Calendar and cyclic both. D.
Yes,
Calendar. D.
D is correct. So here you can see this is figure for this. So cyclic will depend on depth of discharge, discharge rate, limit on SOC, and ambient temperature. So what does the capability curve of energy storage system describes? Its operating point on IV, PV, SI, or PQ curve?
It is B. B is the answer.
Which one?
B. B.
B or D?
Yes. B. Yes.
D, sir. D.
D is correct.
D. D.
D is correct. Now you have to select the storage one time constant battery energy storage equivalent circuit. So which one is correct?
A.
Yeah. A, are you sure?
Storage. Sorry. It is
C.
B.
D is missing here. Thing. D is same. Two L are there.
So then it is C. C is the answer.
C, no, it's one time constant.
B. Then it is B.
Which one? B.
B.
D is same.
B.
Instead of,
B. Bravo. B. First. Second one.
no, B is not correct, no, because here it's inductor. In uh, in battery storage we have capacitor. No, E is not correct. So is energy storage a voltage source or a current source?
It is voltage source. That is why then only C is the left one.
No, none of the above is also option. This option would be correct. C would be correct if two time constant equivalent circuit is asked. So this is for two time constant. D option is same as C. Instead of capacitor, it's inductor. So answer is E. Is it fine? This would have been a correct option A if
Yes.
instead of current source it would have been a voltage source. Had it been a voltage source, this would have been option. Which of the following are not?
Sir, which is the answer of previous?
Answer should be is none of the above. So if this current source is replaced by a voltage source, that will be correct. Equivalent
Yes,
circuit.
sir, for one time. And for
For
two
one,
time constant, sir?
C. Option C.
Yes, sir.
Okay, so which of the following are not quality of good cell balancer? Simple circuit, high efficiency, slow equalization, and control simplicity. Not a good quality. So in exam also you should see this is not incorrect. Such words you should see.
Slow equalization.
Yes, this is correct. It should be fast. Reasons for cell imbalances are uneven temperature, self-discharge, internal resistance, or all of the above.
All.
All of
Yes.
the above.
Week 4. Which of the following is not true for SCADA?
It's B, sir. No time synchronization.
It is A because it is only measuring magnitude, not phase.
Sir, it's B, sir.
Measure
Projection is there.
not true for SCADA. No time. Yes, B is correct. There is no time
B.
synchronization in SCADA because time synchronization for time synchronization only we move to PMU. Also, they are very fast. Also, SCADA is slow. PMU is very fast and also provides time
But in
synchronization.
the question it is written not true.
Yes, so no time synchronization.
This is the true. There is no time synchronization.
Okay,
So
okay.
that is the true one.
Correct, correct.
So now not will cancel each other. So that is why one no is not required.
Yes, yes, it's no, should be correct. Oh, no. Answer is A, sorry.
That is why I
Yes,
said
yes, you are correct. A, this phase angle information is provided by PMU, right? PMU has time synchronization also and phase angle information also. That is why earlier for SCADA we were using this P and Q quantities for state estimation. For PMU we are using I and V because we also know the phase angle. Yes, correct. Sorry for that. It measures both magnitude and phase angle. What do synchronized phasor measurement system measures? Current, voltage, angle between current and
all.
voltage. Yes,
Angle, sir. All.
all. And which component of synchronized phasor measuring system creates the recorded data? Recorded.
Record creates and record.
VDC.
Hmm. PDC. Phasor data concentrator. The next is which of the following is designed to isolate the area of faults and reduce the impact of faults from other parts of the systems.
It's D, sir, circuit breaker.
DFR,
Yes, DPR, not DFR. This is what is full form of DFR?
digital fault recorder.
Yes, so this is only recording. We want to separate, we want to isolate the area. So who will isolate? A digital protection relay. So this is also a recorder.
Yes, sir.
This is
Yes.
monitor. So answer B is correct. Digital protection relay.
Sir, relay only senses, it will not isolate, sir.
Yeah, but it will help in isolating.
Okay, sir. Sir, what are CBM and CBR?
This is monitor, circuit breaker monitor and circuit breaker recorder. This is monitor. So out of these only this is the correct option. Okay.
Sir, 30 number question, sir, means
Which one?
30, sir, means previous.
30. This one.
Next, sir.
Next.
Sir. In
Yes.
this, sir, no time synchronization or A?
Hey, no. Yeah, it is not true. No? Which of these is not true? So SCADA, this is true for SCADA. There is no time synchronization in SCADA. SCADA does not measure phase angle. So this is A option is correct.
Yes, sir. Yes.
It's
Yeah.
not true. Next is recursive DFT increases, doubles, reduces, or doesn't change the number of mathematical.
Reduces.
Which
See,
one?
reduce.
Reduces, yes. Because we only have to calculate DFT once. After that, we can just use a equation. Phasor estimation based on least square error method can be applied for signal with AC, DC, and AC and DC decaying component.
AC and DC both.
No, no. It's only DC decaying component. Only DC. AC decaying component will be something sinusoidal. But it can only deal with the DC decaying component. So it will be this, its form is like this, and we will approximate it as 1 minus t by tau. So because these are linear, so least square can handle these terms. Okay. Because if it is AC, then K naught, instead of K naught, it will be K naught sine omega t e raised to power minus t by tau. Then it will become non-linear. Which of the following is not a non-operational data in WAMS?
Lightning strikes.
No.
Lightning strikes.
It, voltage and current phasors. Which of them is not a non-operational data? This is operational data, voltage and current phasors. The measurement of voltage, current phasor, and breaker status, these are operational data. All these disturbances, power fluctuation, lightning strike are non-operational data. Because these are periodically pulled, not continuously. But like this voltage and current phasor are continuously taken from valves. Next is advantages of the digital relay are self-checking, functional flexibility, system integration, auto reclosing.
All.
All,
All is
yes,
okay.
all correct. In digital relay, the reliability is defined as, which one is correct?
A is
Correct
correct.
trip by total trip.
A.
Yes, correct. Then how many samples must be shifted in cosine DFT in order to obtain the sine terms from the cosine terms? For 16
D.
sam-
D is the answer.
for 16 sample DFT.
And A is the answer. A.
No, no, he is not correct.
C sir, C.
Yes, why is he?
N by 4 sir. 4 square, I guess.
It's because sine and cos differ by 50 degree, ne?
Yes sir.
So 16, 4 by 16 will result in 90 degree.
Yes.
16 for 360, so 4 samples will result in 19 degree, 90 degrees. Let me share again these things. The screen is. Yes, so we are on this question. Using full cycle DFT phasor estimation, the phasor is estimated for a voltage signal with fundamental frequency of 60 Hz and a sampling frequency of 1200 Hz. Estimated angle for 80th sample is 20 degree. So what will be the angle for 83rd sample? So which one is correct? How many samples will be there for each cycle for a sampling frequency of 1200 Hz? Number of samples equals to sampling frequency.
The B is the answer. B.
Yes, B is
70.
correct. So there will be 20 samples. And for each sample, the angle will be 360 by 20, so 18 degrees.
18 degree. 18 degree. So with
Yes,
18 into 3 we have to plus
yes,
20.
correct. So it is 74 degrees. Week 5. Failure to detect unintentional islanding events imposes which of the following events? Malfunction of protective device, equipment damage, threats to personal or crewman safety.
All.
All, all is correct. Then Rokoff IDT requires minimum power mismatch of
D. 15%.
yes 15%. Intentional islanding detection technique. Which of the following intentional islanding detection techniques is the DER driven into an unstable region?
Positive feedback.
Yes, positive feedback. Voltage unbalance is used to initiate which method?
Positive feedback technique.
Frequency set point.
Frequency set point. And PLCC uses
Low.
low energy communication signal. And which of the following is or are protection issues in smart grid? Dynamics in level of fault current, bidirectional fault current, false stripping, all of
All.
these.
All. All.
Yes, one more is there, blinding of protection. And penetration of DR not only changes level, direction, both.
Both. Both.
So it will change both.
Both of these,
Now
sir.
consumers are also becoming prosumers. Utility grid contribution to the fault current is increased, reduced, halved, or not affected due to contribution from DG sources.
Increased.
Increased.
Which one?
Increased. A.
No, it will be reduced.
Reduced. Sorry, reduced because that is cut out.
Yes,
Yes.
because that DG is supplying that a part of it.
Reduced.
Now
Sir,
this, yes,
sir, reduced due to the utility grid contribution to the fault current.
because a part of the fault current will be provided by the DG sources within the microgrid. That's
Sir,
why
it will increase na, sir, total fault current.
no fault current will not increase.
From grid side, there is no current, so that is why that it is reduced.
So
Yes.
the next is microgrid has a load of 600 MVA at a power factor of 0.9 and generation is 500 plus. J300. So calculate the power mismatch. So power mismatch is P load minus P gen. So which one is correct?
A.
Minus 40, sir.
So
Minus
no,
40.
load minus generation. No, not minus 40. How minus 40? What is P load here?
540.
Yes, P load is 540 and generation is for 500. So it should be positive, no? Plus 40.
Yes, sir.
So answer is C. You can calculate here.
No, see, the generation is less and the load is more.
Yes.
So then delta
Sir,
P,
generation is only
delta,
500.
delta P is why delta P is not generation minus load? Why it is reverse?
It is defined in that way only. P load minus P gen.
Okay.
Sir, in generation, it is only 500, or we should consider power factor also.
No, it's already given. 500 is active power and 300 is reactive powers. It's already given.
Yes, sir.
But here for load, only this apparent power and power factor is given. So you have to calculate active power and reactive power for the load. And
Yes,
then
sir.
subtract this 500 plus J 300. So you will get this C. For positive active power mismatch, the superimposed negative sequence impedance is zero, positive, negative, or none of the above.
Zero.
No, no, not zero. Positive, no, negative. Sorry. So it will be negative. Which relay operates under a high negative reactive power mismatch? Under frequency, over voltage, over frequency, or under voltage.
Over voltage.
You can see this. It would be over frequency relay. So we have to see reactive power mismatch. So we have to see delta Q. But this is high negative. So that means this negative side is this. So over frequency limit will be violated. You remember this plot.
Please, could you explain this, sir? I could not understand that diagram.
So this is the diagram for distribution system. So we have delta Q on x-axis, y-axis, and delta P. The active power mismatch on x-axis and reactive power mismatch for y-axis. So I have removed those equations for delta P and delta Q, and they depend upon voltage and frequency as per this plot. So if the this area shows this NDZ, which is non-detection zone. So if it is beyond the reactive power mismatch or active power mismatch are beyond this area, then the relay can detect. So so in this question, it is asked high negative reactive power mismatch. Reactive power mismatch is on y-axis, and if it is negative, that means we have to see this side. So very high negative reactive power mismatch will be taken care by this over frequency relay. So it is governed by equations for delta Q and delta P. I have
Yes,
not
sir. And sir, when NDAZ area will be more or less?
more or less. It depends upon the method which we are using.
Yes, sir.
Hmm. That will determine whether we are using active, passive, or hybrid. Which one we are using.
Yes, sir.
Then next question is limitations of conventional islanding detection techniques is or are. Power quality degradation, complex structure, result in NDZ. All of the above.
All.
Yes. Now we have to select the correct pair, polarizing and operating quantity for a directional relay. So which one is polarizing quantity and which one is operating quantity for a directional relay? And this we have seen before also. So which one is taken as a reference for directional relay? Current or voltage?
Current.
Current, sir.
Why current?
Depend only if more current
Because
is
current direction is changed when there is some fault. But voltage direction may not change.
Then which should be taken as a reference? One which changes or one which is not changing?
So voltage should be reference.
Yes, so that's why voltage is the reference PQ. Current is the operating quantity. Voltage is not changing direction, so that is taken as a reference. Week 6. What are the key deciding features for a battery storage system? Charging, discharging time, minimum number of storage cycles,
All
minimum storage period. Yes, all. Battery capacity is measured in kWh,
ampere
Ah.
ampere are
Yes.
Sir, previous
Which one? This
52.
one?
Yes, sir.
Yes.
All. Okay,
All.
sir. Okay.
55. This is IEEE recommended practice for design of DC auxiliary power system for generating system.
9:46
Hmm.
p.m.
B.
Next, B. Variable speed drive loads are which type of load? Constant
Constant
power,
power.
current,
Constant power.
constant power. Which component of fault current is used in the proposed technique for adaptive protection? Voltage component, phase angle, fault current, positive sequence,
Negative
negative.
sequence.
Yes, negative sequence was used.
Sir, which will be constant impedance?
Here,
Previous, sir. Constant impedance, which will be example.
Bulb is
Ball.
incandescent bulb. No?
Yes, sir. Yes, sir. And constant current, sir. You told so.
Constant current. Constant current load, I'm not remembering.
sensors. In the slides it is written sensors.
Okay.
Yes, sir. You told in previous class.
Mhm. Yeah. So, what is the main advantage of using adaptive protection scheme in the context of smart grids?
D is answer. They can handle fluctuating.
Yes, they can
D.
handle This was the motivation for using adaptive protection because with the penetration of DER, everything is changing bidirectional current, even current magnitude is also changing because they limit the fault current. Different types of DGs limit different fault current. What is the value of coordination time interval maintained between primary and backup relays?
0.3 seconds.
Yes, zero point 0.3 seconds. In a two bus system, the load is drawing 250 current from bus 1 to bus 2 after fault. Yes, the PPT will be available on the same link where on in that problem solving session. You can go to that link and in that Google Drive you can find that PPT. Then after fault the current at the bus 1 is increased to 1600 amperes. Then find the superimposed current at bus 1. What will be the superimposed current?
C is the answer.
Yes, C is correct. So I post minus I pre. Week 7. What do you mean by 5% droop in local hierarchical control? A 5% deviation in normal frequency causes 100% change in output power. 5% change results in 100% change in nominal frequency. So,
A and C is the answer.
yes, loop characteristics is like this. Frequency is on y-axis and this is power.
Technically, if you see a percentage cannot increase
Yes.
100.
Why? Yeah. Even I had this question. I think this was there in the assignment as well. How can the percentage be 1,000?
Even we can say 200 percentage also we say, na? So I can 1000.
For economics, we say it is a rise of 200%, but mathematically, percentages in economics we say it is a increase in 500% and more. So mathematically, only 100% is the maximum. So A is technically, mathematically, A is the correct. However, A and C both are correct.
So
Okay.
100%. So for example, right now, if the output power was at 100% and I deviate the frequency, nominal frequency by 50%.
Hmm.
So and when we say 1,000% change in the output, what
Means
would be after deviation? What would be the power output?
10 times. It will be 10 times.
Suppose load current is 100, suddenly fault short circuit load current is 1000. So we will say it is increased by 10 times. So that is why the percentage in sometimes may increase.
Yes, yes.
Okay.
That is true. That's why it's. So these two equations, these statements are equivalent. Means instead of this, we can only say this A. Simply, we can say A. And next is which one is the type of advanced control technique?
Virtual resistance based D.
So,
D.
sure.
Signaling based, sir. Signaling.
Virtual resistance based. Correct. And which one of the following statement is correct? So, first is hybrid storage system combines a battery with its energy management and ultra capacitors. Ultra capacitor is a low energy and high power density device.
C both.
Yes, ultra capacitor is low energy, high power density. Cannot provide long discharge durations. And lithium ion is opposite. Opposite? In comparison to ultracapacitor, it can provide both high. So, in comparison to ultracapacitor, its power capacity will be lower, and it provides high energy capacity or energy density. Which of the microgrid has a DC bus as its main bus?
DC microgrid.
DC microgrid.
Yes. Which of the following are the operating modes of a grid?
Both.
Both, sir.
Hmm, good. Control variables in microgrid are,
P, Q, V, and F.
yes. And if it is only if it's a DC microgrid, then
Then remove F then and Q.
Then P and V, sir.
yes. So
P
then
and
it will be P and V. No Q and F. Which of the following is a type of intelligent control technique?
multi-agent based.
Yes. Which one is a type of decentralized microgrid control?
DC bus signal.
Yes, DC bus signal. What is the major drawback of voltage level signaling? Number of sources in system are restricted, non-linear, or significant voltage deviation are permitted. Answer for this is A. Move to week 8. DCOPF is used for optimal power flow studies for,
AC.
yes, for AC. Why not for these DC? Then why is it called DC OPF?
Because we approximate it in a linear system.
Although it is used for AC but called as DC.
Because of linearization.
Yeah, so it's approximation, linear approximation of actual AC OPF. Which of the following statements is correct? Genetic algorithm is robust, adaptable, and takes less execution time. And binary linear programming solves a system of linear equalities or inequalities in binary unknown.
B. Only 1 second.
Only two. What are disadvantages of cyber physical system? Cyber attacks, network congestion, malicious
All.
control.
All.
Yes, all.
Sir, previous slides.
Previous question.
Yes. Okay, sir. Okay.
So,
Okay, sir.
can you name some cyber attacks? Different types of cyber attacks?
Man in middle attack.
Yes, management.
DDoS.
Which one?
DDoS, denial of service.
Yes, DOS, denial of service. Then there is one more. False data injection. So, which of the following is an indication of real-time balance between supply and demand in the power system? It's easy.
Frequency.
Frequency. Now you have to match this with this left side to the right side. So which option is correct for inertia?
Inertia is on cycles, primary in seconds, and secondary is in minutes.
Inertia synchronous machine.
Inertia with synchronous
Synchronous
method.
machine.
Yes.
So for inertia, it is 1 and 4.
1 and 4. Yes. Cycles. What about second primary frequency response?
Primary is in second.
Order of seconds.
Yes. And secondary?
Order is in minutes.
Minutes.
But for secondary, I think
Cycle.
minutes.
Or secondary?
Minute.
For me,
Minute.
minutes.
And is this option applicable to any of these frequency responses? We just discussed the slides back.
Primary,
No, no, not primary.
significant communication infrastructure.
Secondary. Oh, this is AGC control. The AGC requires communication. This is based on governor action. And this is inherent inertia within the rotating mass. So secondary requires significant communication. All these three are automatic in one sense. But tertiary is not automatic. Okay. So this is correct. Yeah, this is same thing is explained here. This is taken care by spinning and non spinning. This is not automatic. Energy storage can provide all these services. Which of the following is this is already done? What are the different demand side management strategies? Peak reduction, flexible load, load growth, off peak shaving.
Peak reduction.
Okay.
It is off peak shaving is also correct.
Load growth.
So
Load growth.
okay.
A and C.
A, C, and D. You are saying
No sir, A and C. D is off peak saving not. It is
it is
A, C, and D.
A, C, D. Sure.
why D sir off peak.
I have changed this option.
A, B.
A, B, C. So this is actually peak shaving, but off peak we don't want to do off peak shaving. Means it will further deteriorate the plant load factor. You want
Yes sir.
load curve to be flat. So answer is A, B, C. We can see here.
Why flexible load?
This is we can see here. These are the 6 types of demand side management strategies. So this one is peak clipping or also called as peak shaving. Then this is load shifting. Just shift the load from peak to off peak. Valley filling, increase the load during off peak. And these are strategic conservation or load growth and flexible load shift. And that means you can achieve any kind of load shift. Or this is theoretical.
Flexible load is, I'm not getting it. How it is there?
That means you can achieve any kind of load shape as per your requirement. Physically, very difficult to implement, but theoretically, theoretically it's a type, but very difficult to achieve this. That means anytime you want any kind of load shape, you can achieve it. You can change it. You can make it the way you want. But that is not so easy. So many consumers are there. They are not going to do what the operator says because they have their own requirements. Okay. So next is which of these is or are a type of dynamic pricing based demand response strategy.
Time of use.
Okay, only time of use.
No, we can say incentive also we can give if people are shifting to off peak hours.
But that will be incentive based. Dynamic pricing based is different.
Real time pricing also we can do. If the load is more, we
So
can charge more.
A
So,
and B.
so C is also correct if we say.
Yes. So ABC is correct. You can see here all these are different demand side management strategies. The first is energy efficiency. So shifting from CFL to LEDs is example of this. Energy conservation. This requires changing consumer behavior, which is not so easy. Then demand response. In demand response, we have these three controls based, centralized or decentralized. Price based also there are two types: dynamic pricing and incentive and penalty based. So dynamic can be these three: time of use, critical peak pricing, and real time pricing. Incentive based are these three, and then load based, task related or energy related. Okay. So next question is PV array provides inertia, active power control, both or none?
Active power control.
Yes, active power control.
Not both.
Yeah,
Inertia also, sir.
both or active power
Both.
control.
Both.
Only active power control, not
Yes, it should be this
Only active person.
active power control. This option is not correct. I will change it.
Both will.
So next is select the correct option with respect to frequency support services. Tertiary frequency response is based on governor action. Interconnection frequency deviation can result in load shedding. Energy storage can provide frequency support services, and response time for primary frequency services within 2 cycles.
D is the correct answer.
Which one?
Last response time of primary.
Option D, sir. Last.
Is this correct? Are you sure?
Yes, sir. D is correct.
Oh, so many hand voices for D. Please check again the response time. Check it once again.
2 to 3 cycles it is written. So
But it is for primary frequency services. That is for research. Just now we in the previous slides we saw that for primary services it is within seconds. 2 cycles means it is milliseconds. So inertial response will be of the order of cycles.
Answer is answer is B.
Yeah, B is correct. Interconnection frequency deviation can result in load shedding. So this should be seconds for for primary frequency services, not cycles. That means milliseconds. Okay. Next is, which of the following is a desired goal of an utility?
Flat load curve.
Yes, we
Flat
want
curve.
we want a flat load curve. Week 9. So which one is correct in the MPPT mode of solar cell?
VOC greater than VMP and
C is the correct answer.
IMP greater than IAC. A should be
C is the correct answer.
C.
C.
Yes, C is correct.
C. I,
We have here, this is short circuit current, this is open circuit voltage, and it is peak is somewhere here. So here VM and IM. So both are less than the short circuit and open circuit voltage. So DFIG is a type of, which type of machine? Squirrel cage, slip ring, or both, or none?
Slipping, sir, slipping.
Yes, it's a
So
slip ring
three.
machine. So DFIG is which type of wind turbine? We have type 1 to type 4. Type 2, type 3, type 4. Which one is this DFIG?
Type 3, I think.
Yes. Type 4 is PMSM. Type 1 is fixed speed. And this is variable speed, but not doubly fed. So next is, a private entity has taken a contract from government to establish a hybrid microgrid that should continuously operate in grid connected mode. Which of the following configuration is economical as well as efficient?
C, AC-DC coupled hybrid microgrid.
Yes, C is correct. Next is, you have to select the correct statement. Internal resistance is a temporary reason for cell imbalance. Cell to cell is a passive method of cell balancing. Or shunt reactor resistor is an active method of cell balancing. All are incorrect. So which one is correct option?
All are incorrect.
All are incorrect.
Yes, internal resistance is not temporary reason, it's always there. And these two are switched. The number of cells connected in parallel provides a higher voltage, higher power, or higher current carrying capability, or none.
high current.
High.
Current, sir.
High.
Yes, high
High
current.
current.
And if they are connected in series, then
Voltage. High voltage.
high voltage for series connection. So by using series, that's why we use series parallel combination for increasing both. Yes.
Sir,
What's
please, could you open the 93, sir, 93 question? Most of the persons are saying AC/DC, but you have highlighted AC coupled only.
oh? So that's wrong. It should be ACDC.
Sir, but in assignment, AC coupled hybrid is given as right answer.
Which one?
B is given as right answer in assignment. One of the assignments, I think, sir.
Okay. AC coupled. This one is
This is not an assignment question.
The assignment question. I think.
This is week 9, right?
No, no,
Is
this
it because it is to be continuously operated in grid connected mode?
Yes. Hey,
Because it is the requirement is not to have it operated in isolation mode, right? The AC/DC hybrid would be most efficient if you require both operation, autonomous and grid connected.
whenever microgrid is there, so it can operate in both.
Yes, yes, that's right. But then the question says it will be in grid connected mode. So if it is in grid connected mode, the most economical would be having less storage, right?
Less storage.
Storage, unless you need to give ancillary services, which are expensive in deployment and operation and everything. Is it from that point of view I'm asking?
So more economical
In
and
option, sir, there is also we have to establish a hybrid microgrid. So that may be AC and DC. Hybrid microgrid we have to establish.
in hybrid microgrid there are three combinations. One is AC coupled hybrid microgrid, second is DC coupled hybrid microgrid, and third is AC DC coupled hybrid microgrid. So in AC coupled hybrid microgrid, these generators and the storage are connected to common AC bus.
Yes, sir.
And
Yes.
DC
So
coupled, there
here, so
yes,
there, and you want the grid to be present all the time, then it becomes most effective, right? Here it
yes,
is mentioning grid connected mode. So I'm
yes,
asking, is that the reason why it says the AC coupled should be the correct answer? When you
yes,
have also
yes,
isolated mode to be or autonomous mode to be considered, then definitely it is AC/DC coupled.
yes. So
But
correct.
since it is mentioning only the grid connected mode, I think then AC coupled would
Yes,
be more
that is
economical and efficient.
that is correct. This is correct. So that is the main reason because it is continuously operating in grid connected mode. So I also that's why the answer is this AC coupled hybrid microwave. So if yes, you are correct. If this it's a remote area, then this would be considered ACDC.
Yes.
Yeah. So is this clear?
Yes, sir.
This, this is good observation. So let us move. We're on which question? 95th, I think. Yeah, this was done. So that is why I was telling that is why we have these series as well as parallel combination. So in batteries, we want to increase because individual cell provides less voltage as well as less current. So we want to increase both. IEC 62840 standard is related to
I think D.
yeah, battery swapping. So what is battery swapping?
Sir, EV batteries can be used as inverters into grid.
No, this is something else. Charge, exchange, discharge, and charge. Yeah, that is correct. So what you can do if you have a two-wheeler, four-wheeler, it's not possible. But in two-wheelers, what you can do if you have batteries, you can. They are designed in such a way that you can remove the battery and go to a station where it's a battery swapping station. So you take out your batteries and put it back to the station and take two new batteries and then use it in your two-wheeler by paying a fixed amount. So in such a model, generally the battery will not be owned by the vehicle owner.
Yes, sir, you're right, sir. Otherwise, our people will give at the end of battery life, they will exchange the batteries, sir.
Yes, so that will be a loss for the company. So here the battery will is not owned by the vehicle owner. So
First battery, sir, we have to buy for the vehicle.
sorry.
Otherwise, how? First battery we should buy. Otherwise, how exchange will? First
So I
battery.
could not hear complete. Can you please repeat again? First.
Sir, he is asking at the time of purchase of bike, we have to
Yes.
purchase the batteries also or not?
Means
No, if the battery is not, if vehicle owner is not owning the battery, then no, he will not purchase. Or or the other model is that the company will provide that within the car. So they vehicle manufacturer and the battery swapping company, they will be having a tie-up. So that is
yes,
one. So there are different models. So one thing is that they can. One model is also this that one battery will be within the. It will be owned by the vehicle owner only. Second battery you can swap. So that will be provided by a company, and then you can go to station and swap this one when this is discharged. But this is still your own battery. It will be fixed, or it can be removable, but it is owned by the vehicle owner, so he can charge it on his own. This is also one model.
Currently, this
yes,
is
sir.
very famous in China.
Yes, in China it is there. So you just remove your batteries, put it back, charge it, and take new batteries,
Yeah, yeah.
charged batteries. For this, we need a few good ecosystem for all these battery swapping stations. In India, also few companies, I think Ola is planning to have these stations. But initially, now they are planning this EV station, charging station. We don't have charging stations, public charging stations. There are few in Mumbai. They have in malls parking. They have one or two charging slots for four wheelers. So gradually it will increase. So next question is the terminal voltage of a battery decreases with increasing charge rate
C. Increased temperature.
in state of charge. Yes, with increase in temperature, the terminal voltage decreases. Next is the interlinking converter works on the principle of which one? Equalizing DC side per unit voltage with per unit frequency, DC side per unit voltage with AC side per unit voltage, DC side per unit voltage with AC side voltage angle. Or
A,
like,
A is the answer.
he is correct. Because on DC side we want voltage to be regulated, and AC side we want frequency to be regulated. Next is BMS monitors the values of
Oh,
voltage, current, temperature. So D,
All of
all
the
battery management system. It will measure all these things. It will provide status. It will provide state of charge, state of health, and all these status we can see and take data from it to data log. Which of the following control loops are there in grid connected PV generation? MPPT control, current control, grid synchronization, all of the three, or only A and B?
All,
All of the three.
all.
Yes, all of the three. We need MPPT control, then inner current control also, and grid synchronization. So grid synchronization, this is done by which component?
PLL.
Yes, PLL does this job. Select the correct option for DC link capacitor. Capacitor voltage. So DC link capacitor voltage should be
More than.
rated more than the pay grid voltage. Why more?
Then only that the energy will flow.
Yeah, and only the power transfer will happen. So we need that voltage difference. So with for sufficient power transfer, we need this voltage difference between the DC link because power is flowing from DC side to AC side. For that, we need this voltage to be higher. We can. Which transformation converts ABC to DQ0 reference frame?
A mark.
Yes. And what about Clark? What will Clark do?
Alpha beta.
Hmm. So ABC to alpha beta. So which one is stationary and which one is synchronously rotating frame out of these two?
Alpha beta is uh, rotating.
Sure.
Stationary.
Sorry.
Alpha beta stationary.
Yes, alpha beta is stationary and DQ is rotating. This we discussed in last class. Rotating frame. Is this clear or do you have any doubt? I can explain it again. It's important.
Can you please explain it again?
Yes. So if we have ABC quantities, phase A, B, C, we can represent these three phases by a space phasor. Let's say this ABC phasor represented by this phasor FT. So if now we have two frame of reference, let's say it's so we have three in one sense. So one is this space phasor, which represents this ABC quantities, and second is alpha beta. So here we have alpha and beta. So these two are fixed. Alpha beta, this frame is fixed in this position always. FT is rotating. So ABC quantities are changing, but is this frame, this alpha beta frame is constant. It is not rotating. So we can write if this angle is theta. So I can write so beta will be equal to ft cos of theta and alpha will be ft sine of theta. Okay.
Okay.
So this frame of reference is fixed. It is not rotating with this ft. So the alpha beta quantities that we get are sinusoids. Then there is another frame of reference which is dq. So this is dq. So this frame of reference dq This is also rotating. Let's say ft is rotating with omega and dq is rotating with omega dash. So both are rotating. So if omega is equals to omega dash, both are rotating at same speed, then what will happen?
dq is stationary with respect to ABC, sir.
Yes, dq is stationary with respect to ABC, correct. That is why we get dq quantities as DC signals when both are rotating at same speed. So PLL does that work of ensuring that the dq is rotating at that same speed. So it will try to get that theta from the that grid voltage, and it will get the same speed, and then dq will also rotate at same speed, and we get dq, these DC signals. If they are not rotating at same speed, then they will not be, then these two quantities d and q will not be DC signals. So in transients, so in steady state both are rotating at same speed, but when there are faults, then it will change. Then this will change. It will not be DC. In transients, there will be some changes, but again steady state it will be same. So PLL try to do this. So with reference to each other, both are stationary. But if one is an external observer, then for him dq is rotating and alpha beta is stationary. With respect to each other, dq and ABC are stationary. Okay.
Yes,
Yes, sir.
understood.
Then inverse Park and Clark will be opposite from dq to ABC and alpha beta to ABC. dq 0, alpha beta 0 to ABC. Now you have to match this. Match the following with respect to a synchronous generator. So first is under-excited, over-excited, and normally excited synchronous generator. What will happen? When will it absorb or inject reactive power or UPF?
A2 with 3.
A2?
A2 with 3. C1.
Excited will absorb, excited will inject, and normal excited is unity.
Yes, correct. So normal excited is unity power factor. Under-excited means it will absorb, and over-excited means it will inject. Yes, so this is correct. Which one is a voltage regulating device?
A and B both.
Yes. On tap, on load step changing transformer and D STATCOM. Both. Now you have to identify a correct statement. First is battery and supercapacitor are connected to an isolated DC microgrid through unidirectional buck boost. Both are connected through bidirectional buck boost. Battery is connected through bidirectional and not supercapacitor. And D is neither.
B is the correct answer.
Yes. So
Bidirectional buck boost.
why do we need bidirectional?
Charging and discharging.
Yes. For charging and as well as discharging. So we need bidirectional. Next is multi-parallel inverter systems connected to the grid act as voltage sources, current sources, or power sources.
Current sources.
Current sources. And in because of
In sir, isolated mode, bidirectional will be needed in previous question.
previous question,
In isolated mode,
yes,
bidirectional will be needed converter. Bidirectional converter.
Bidirectional will be required.
To charge discharge of the battery.
Yes, because suppose if PV is generating, load is less, and battery is not charged fully, so it can charge. And if PV is not there,
Then it can discharge to other routes. Yes, sir.
yes.
Yes, yes, sir.
So both are possible. Where were we? Here, current sources. Because they are connected in parallel, so we saw that two types of current are there: interactive and common currents. So next question is I think on that only. Select the correct statement in the context of multi-parallel inverters. So common and interactive currents will be unstable if the poles of their characteristic equation lie in the right half of S plane. Interactive currents are one that flow into the grid. Problem of interactive and common resonance occurs in L filters inverted due to their first order nature. All are incorrect. So which one is?
A is the correct answer.
Why is it right half of S plane? So when will it be stable?
Right half is unstable in that pole and
Why?
negative. Left half is stable. If the roots are in left half, then only it is stable.
Yes. So if this is a transfer function, so poles are on which side? Left side or right side?
Minus A. Minus
Yeah.
A it is.
Left side, sir, minus A.
Yes. Minus A, so it will be something like e raised to power minus 80. If it is S minus A, it will be right side and it will increase. It will keep on increasing. It
Yes,
becomes a.
sir. Yes, sir.
Next is select the correct statement. First is nonlinear loads induce harmonics in the system. Harmonics can cause interference with telecommunication lines, and dynamic voltage restorer is a power quality mitigation technique.
All is the correct answer.
Yes, all are correct. For an inverter with an LCL filter to be stable, it is required to ensure stability of interactive and interactive currents, common currents, and our inverter with LCL filter is always stable. Which one?
Interactive current should be as less as possible.
No, we are talking here about stability of the LCL filter. So an inverter with an LCL filter, we want it to be stable. So for that, which should be stable? Means both the current should be stable, or only either of them, or it doesn't matter.
Interactive should be interactive current.
Why not common current?
Common current is to be stable. Common is
Common current will be, sir, when there will be unbalance, unstable.
Common current will be going into the grid, and interactive current will be within the between these shared between these two inverters.
C
So for
is the correct answer. C.
Then common current only, sir.
for overall stability of the inverter, we will require both stability of both the currents. So So for entire system stability, both should be stable, right? Not just common current. Both have to be stable.
So then B and C is the answer.
So A is interactive and common current.
Yes, yes.
A is correct. Next is disadvantages of passive filter is or are. So large size filter is required to cause overcompensation. Change in system detunes the filter and causes increased distortion. Adaptable to various varying system condition as size and frequency can be quickly altered. Which one is the disadvantage? Or all? C, D is all.
B, B.
Which one D? A, B, C or D?
Change in system detunes the filter, I think.
This is the answer.
So which one?
Option A, sir.
Option A only.
Change in system
A and B.
records. Then A and B, sir. Both.
A and B is correct. Hmm. As soon as system change, because these are passive. They, once designed, they will remain fixed. So if the system changes, we'll have to.
It will cause distortion. Yes, sir.
We need active filters. Week 11. Select the correct statement. AC-DC distribution system is more complex than a pure AC distribution system.
Yes, sir.
AC-DC system has available load flow methods for transmission can also be applied to AC-DC distribution. So which
A is the correct.
Option A, sir.
A is correct. Next is what are the main features of power flow control strategy in energy management system? Peak load reduction, effective control and management, and increase.
All.
Yes, all. Now this is regarding the PHIL and CHIL. So there are two types of HIL, hardware in loop. One is power hardware and second is control hardware. So identify the correct statement.
B,
Yes.
sir. B. Control signal,
PHIL application
low
controls
voltage.
high voltage. Control CHIL low voltage.
B is the answer.
A and B is the correct answer. A, B, and C.
Why A?
B is correct.
B is correct.
In A, you convert it into low afterwards. I mean, or rather, the transmission, the signaling is in low, but for hardware, you step up if required. But CHIL is always low.
Control power, high voltage is required. So A and B is correct.
But control signals are in PHIL still low voltage, right?
So in between we have this power amplifier, right? That will amplify. But
Yeah.
control the input which is
The
it is receiving and
signals are low.
output both are and so that control that is low voltage. That is why only B. What are the different operating modes of power flow control strategy? Peak, off peak, isolated, or all?
All.
All. What are the different types of buses in AC DC system? AC and DC. AC has how many types? Three types.
Option D, sir. Reference DC, PV.
D, sir.
Yeah. So AC has which one? Slack bus and
PV, PQ.
PVPQ.
so PV. Which one is load bus in this PV
PQ, sir.
Q is load,
and PV is
Generator.
generator.
generated or it can be voltage controlled also. Then DC we have two.
P and V.
Yes, P and no Q and F here. In isolated modes of control strategy, if PV is more than load and battery SOC is less than 90, then what will happen? PV operates at MPPT, load are met using conventional grid, battery supplies the load, or PV operates at off
A,
MPPT.
A,
Of MPPT, sir.
PV operates at
Which one operates at?
A.
Yes, A
AC.
is correct. Because battery is not charged yet, so it can charge it being by being at MPPT.
But
DC,
it
yes,
is more than load, sir.
sorry,
All generation is more than load.
yes,
So
more than loads. So and because battery,
then it can charge the battery, sir.
yes, it charge.
Without MPPT, it can also charge.
Yes, it can charge. But if you want to charge it quickly, we want it to be as soon as possible. It can charge. We will try to draw
Yes,
maximum power till it charges reaches 90%. After that, we again go for draw.
yes, sir. Yes.
So next is DC microwave functionalities. Which of these are DC microwave functionalities? Ensuring stability, flexibility, scalability, and grid support services.
I think it is all.
All,
Yes,
sir.
all all are correct. Select the correct option for control layers in DC microgrid.
Vidya,
B, B, B.
With B, yes, zero primary, secondary, and tertiary from lower to upper, from bottom to top. Next is type 2 DG, delivers Q, delivers P, and Q delivers P, and all of the above.
B, P and Q.
That's B, P, and Q. So these are synchronous machines. Type 1 is they deliver only P, which is PV or fuel cell. Type 3 only Q, synchronous condensers or compensator. Type 4 deliver P but consume Q like induction generators. So next is select correct statement regarding the controllers. So PI controller requires only sinusoidal input. Only. PR controller works only with DC input. PR controller for grid tied inverter requires ABC to DQ, zero transform or none of the above.
None.
Yes, correct. Good. None is correct. So this should be alpha beta 0. Last week 12. So what are the working modes of DC microgrid? Grid
All.
connected. Yes,
all, sir.
all. And which of the following optimization model is used for optimal storage siting?
A.
Yes, MILP. So integer variable here is whether storage is connected to a bus or not. With what is or are the probable causes of errors during PHIL? So these questions are same as what we discussed last time.
All. All.
Or in a DC microgrid connected to AC grid, if power generated by PV and energy storage is less than DC load connected to DC bus.